Welcome to Summarize Science, where we break down fascinating new research. Today, we're looking at a young star system called HD 166191, which recently gave astronomers a front-row seat to what appears to be a giant collision between forming planets. Previous observations with the Spitzer Space Telescope saw a dramatic brightening in infrared light, which was interpreted as a massive cloud of hot dust created by a powerful impact in the system's inner, rocky planet zone. This was an exciting discovery, as it's rare to catch such a violent and important event in the act. To learn more, a team of researchers used the ALMA and SMA radio telescope arrays to get a different view of the system. These telescopes observe in millimeter wavelengths, which allows them to see the cooler gas and dust that exists further out from the central star. Their observations successfully detected a disk of both dust and carbon monoxide gas orbiting the star. The data showed a classic double-peaked signature, which is the telltale sign of material rotating in a disk. However, the team looked for a key chemical signature of a high-speed rocky collision, silicon monoxide or CO. Despite a careful search, they didn't detect any, placing a strict upper limit on how much could have been produced or survived. Another surprise was the lack of change at these longer wavelengths. By comparing new ALMA data from 2024 with older SMA data from 2014, before the collision happened, they found the brightness of the outer disk was stable. This indicates that the effects of the inner system collision didn't dramatically affect the outer parts of the disk. By modeling the telescope data, the scientists determined that both the gas and dust are confined to a surprisingly compact region. Nearly all of the material is contained within about 20 astronomical units, which is roughly the distance to Uranus in our own solar system. So, what does this all mean for the evolutionary state of HD 166191? This chart compares its dust mass to other known systems, showing it's in a very interesting middle ground. It's not a young, gas-rich protoplanetary disk, but it's also not a settled, gas-poor debris disk like our own asteroid belt. The system appears to be in a transitional phase. The data suggests the inner region, where the collision occurred, is largely depleted of gas, allowing planetesimals to build up speed and collide destructively. Meanwhile, the outer regions still contain a significant amount of primordial gas left over from the star's formation. To recap, this research gives us a unique snapshot of a planetary system at a crucial, chaotic crossroads. It shows that the final, violent stages of building rocky planets can happen while the system still has a large reservoir of gas in its outer regions. This helps scientists piece together the complex timeline of planet formation, suggesting the destructive but creative process of giant impacts can begin while a system is still transitioning out of its infancy. Thanks for watching Summarize Science.